What does Earth actually look like from the frozen edge of our solar system? From over 3.7 billion miles away, the view is quite different from what we are used to. There are no cities, no roads, and not a single flicker of human light to be found. What you will find is a tiny, pale dot, just a few pixels across in the darkness. Yet, those few pixels contain everything we know: our oceans, our atmosphere, and the life that sustains it. That dot is home, the most obviously alien and inhabited world in the entire sky. Since we are exploring everything about this distant world, get comfortable and enjoy the view. Let's set the stage. Pluto sits crouched 3.7 billion miles away from the Sun. Its orbit is highly eccentric, meaning its distance from the Sun changes significantly over time. Imagine driving there in your own car at a steady 80 miles per hour without stopping. You would never stop for gas, for the bathroom, or even to sleep. Do you know how long it would take? Something like 5,000 years. That is why when the astronomer discovered the distant planet in 1930, he didn't see a landscape, he saw a dot. One small, white dot, creeping slowly across the constellation Gemini, was his only evidence. Even in the 1990s, with the Hubble Space Telescope, Pluto remained a blurry, gray, little ball. Let's set the stage. Pluto sits crouched 3.7 billion miles away from the Sun. We had to wait until 2015 for the New Horizons probe to reveal the mountains of ice and a vast plain shaped like a heart, proving that our tiny dot was a world after all. Now, picture yourselves standing there among the ices, trying to find good old Earth. How would you do it? You would look with the naked eye, but there is a catch. If you look for it on the dark side of the sky, you will never find it. Because the inner planets ride orbits that hug the Sun, while you are out on a giant external orbit. From where you stand, an inner planet is always glued to the Sun, never letting go. Before we move on to answering the question, be sure to subscribe to our channel. Astronomers have a fancy word for how far a planet can wander from the Sun: maximum elongation. And for Earth seen from Pluto, you know how big that wandering is? 1.5 degrees. To picture it, take 3 full moons, line them up, and that is the maximum Earth can stray. And watch out, because that little geometric fact has a wild consequence. Earth has phases, just like our moon, just like Venus. When it swings closest, it turns its back and disappears. When it is on the far side of the Sun, it would be a beautiful, full Earth. But it is hidden. The only decent moment to catch it is that brief window when we see it lit halfway.
Earth seen from Pluto would actually be visible to the naked eye, shining at a magnitude of 4.1.
And that is roughly 6 times brighter than the faintest star you can see by eye. And you would even be able to make out our moon, right on the ragged edge of human vision. But the supervillain of this whole story is him, the Sun. Seen from Pluto, the disk we are so used to back on Earth shrinks down to something tiny. Almost a pinprick, like a star, but that star still blazes 300 times brighter than our full moon. It is like having a flashlight aimed straight into your eyes from 3 feet away. To switch off that beacon, you need a special scientific gadget, the coronagraph. A kind of ultra-precise optical mask you slot into the telescope to hide the solar disk. We have to level up. Say you Plutonians grow up to be professional scientists and get to use an advanced space observatory parked in orbit out there. Now we can really zoom, and here a key word comes into play: angular resolution. The angular size of the smallest detail an instrument can reveal. Hubble, as everyone knows, has hawk eyes, separating details as small as 0.05 arcseconds. Now Earth is 7,918 miles wide and sits 3.7 billion miles off. A quick calculation tells us that from that distance, it shows up as a tiny disk. So on Hubble's sensor, the image of Earth would take up exactly 9 pixels. Think about it. A planet as complex as Earth captured in an image just a few pixels wide. And yet, a sharp Plutonian astronomer could start to pick out quite a few things. The existence of continents, the oceans, the polar caps, and the big cloud systems racing along. And here is the most spectacular thing of all: the weather. Watching Earth day after day, the image would keep changing its face. There is a trick of light that is pure magic. The ocean glint, the mirror-like reflection off water, fired off towards space. As Earth spins, water acts like a mirror, bouncing the sun's rays straight toward Pluto. Flash. One of Earth's pixels suddenly lights up, becoming 3 or 4 times brighter than the others. That flash would be mathematical proof that Earth is a world covered in sea. And there is one last masterstroke, and it has a gorgeous name: the red edge. Plants use the sun's light to live, but they bounce the infrared light right back like a mirror. They do it so they don't overheat and cook under the sun. At a wavelength of 700 nanometers, the brightness shoots straight up. That leap is the signature of chlorophyll, the signature of green life. The scientists on Pluto would notice the planet makes one full spin every 24 hours. And they would notice the infrared red edge peak rises and falls over the course of a year. In summer, the leaves are out, but in winter, they are buried in snow. Earth, seen from 3.7 billion miles away, would look like it is literally breathing. And if they compared it to the moon, they would find nothing but a flat, dead rock. The proof comes from another of the astronomer's superpowers: spectroscopy. You take the light reflected by the planet and run it through a prism. Each molecule eats a precise sliver of that rainbow, leaving a black line in its place. Those spectral lines, all together, form a chemical signature, impossible to fake. The Plutonian scientists aim their spectrograph at Earth's pixels and read the barcode.
And what do they find? Loads of water vapor, confirming the clouds are water.
A healthy dose of carbon dioxide, the blanket that keeps the planet nice and warm. And then they find the thing that would make every scientist on Pluto leap for joy. An atmosphere stuffed with free oxygen and its protective cousin, ozone. Oxygen is a troublemaker of a gas, a real bully of chemistry. It sticks to everything, rusting iron and reacting with rocks, eventually vanishing. So finding a planet with 21% free oxygen means there is a tireless source. A giant, tireless pump working every second to replace what gets used up. And on Earth, you know what that source is? Life, the endless forests, and the phytoplankton. It is what astronomers call a deep disequilibrium, an air that couldn't exist on its own. And so here it is, the final conclusion of the planetary researchers. They couldn't prove there are cities, cars, or roads, and they are too small. They know nothing of our history, nothing of the internet, nothing of us. And yet, they would conclude with absolute scientific certainty that this third planet is alive. Boundless oceans, a complex atmosphere, and a chemistry profoundly transformed by life. To us, Earth is the obvious backdrop of everyday life, sometimes even a little boring. School, work, traffic, rain, all the things we take for granted. But seen from 3.7 billion miles away, through the mirror of a telescope on Pluto, our home would officially become the most fascinating, desirable alien planet in the entire universe.
And that planet is ours.
So that is your whole world, shrunk to one living pixel at the edge of the solar system. Now keep pulling back. What would the entire solar system look like to someone staring in from the outside? From the dark between the stars. That is where we go next. They couldn't prove there are cities, cars, or roads, and they are too small. A giant, tireless pump, working every second to replace what gets used up.